Hello class, today we are going to discuss rate law. So rate law is also known as rate equation.
So what's rate law? Rate law is an equation used to relate the rate of a reaction to the rate constant and also the concentration of reactants raised to some powers. So the general formula or equation for rate law is, so by using this example, I can write the general rate law, which is rate is equal to K to the concentration of A raised to the power of m, and concentration of reactant B raised to the power of n. So in rate law, we only use to show the relationship with reactants. So only reactants is included in the rate law. So K is a rate constant, and n, the power of m, is a order of reaction with respect to the reactant A, and n is the order of reaction with respect to B. And the overall of the reaction for this reaction is m plus n. So another example, when I have A convert into B product. So I can write my rate law, the general rate law, as rate is equal to rate constant K and concentration of reactant A raised to the power of m. What is a rate constant? K. So based on the reactions, we have the rate law, which is rate is equal to K to the concentration of reactant A to the power of x, and concentration of reactant B to the power of y. So this is our general rate law. So we can say the rate constant K is a proportionality constant between reaction rate and the concentration of reactants. So it means that K is a constant between the two variables, reaction rate and also the concentration of reactant. And the unit of K normally depends on the value of x and y. So this one we'll see later how to calculate the rate constant K. What's reaction orders? So based on the general rate law given, rate is equal to K, concentration A, power of x, and concentration B, power of y. So the rate reaction order here is my x and y. So actually your reaction orders, it will be integers starting from 0, 1, 2, and so on. And to write the reaction orders, we can use any letters to represent our reaction orders. It's not necessary must be using x or y. Sometimes you can use m, n. And reaction orders is used to define how our rate is affected by the reactant concentration. And remember, our reaction orders cannot be predicted from the stoichiometry. It cannot be predicted from the stoichiometry coefficient. It must be determined experimentally. And then for the next few slides, we are going to see how to calculate the reaction order from the questions. So as we mentioned, the order of the reactants is not related to the stoichiometric coefficient of the reactant in the balanced chemical equation. So what does it mean is, for example, I have this chemical equation where chlorine react with Cl2 to produce FClO2. So my rate law is written as rate is equal to K, concentration of F2 multiplied by the concentration of ClO2. So based on the rate law, the order of the reaction order for chlorine gas is 1, and the reaction order for ClO2 is also 1, based on my rate law. But you can see, so this is my rate law, but you can see ClO2, the reaction order is 1, but in the coefficient, in the stoichiometric coefficient in the chemical equation is 2. So we say the reaction order is not coming from the stoichiometric coefficient. So this one we have to calculate. So you cannot straight away predict from the stoichiometric coefficient. So this is wrong. So based on this one, I can say the overall reaction order for this reaction is 1 plus 1. So I can get the overall reaction order is equal to 2. Based on this balanced chemical equation, I have nitrogen oxide and hydrogen gas as my reactant. So my rate law, I will have these two reactants included in my rate law. So the rate law is rate is equal to rate constant K to the concentration of nitrogen oxide to the power of 2 and concentration of hydrogen gas. So based on the given rate law, I can say nitrogen oxide is second order, hydrogen gas is first order, and the overall reaction order is third order. Foundation syllabus, we are going to cover 3 types of order of reactions: zero order, first order, and second order. So zero order of reaction is when the overall reaction is equal to 0. The rate law can be written as rate is equal to K reactant A to the power of 0. So when the reactant A is to the power of 0 is also equal to 1, so we can write the rate law as rate is equal to K. So when rate is equal to K, means that my rate of reaction is not dependent on the concentration of A. So it is zero order in A and also zero order for the overall reaction. So the graph for the rate against concentration of A, I will get a straight line, because no matter how my reactant A increase, my rate will remain the same, because the rate is equal to the rate constant K. So my rate of reaction will remain the same. First order of reaction, the general rate law is written as rate is equal to rate constant reactant A to the power of 1. So if your reactant A doubles, it will also affect my rate of reaction, which my rate will also double. So it is first order in A, and the overall reaction is also first order. So the graph for the rate against concentration of A, I will get a straight line. So we say the rate is directly proportional to the concentration of A. So when my A increase double, my reaction rate will also double. When my concentration of A triples, my rate will also triples. So it is directly proportional. So second order of reaction is when the rate is equal to K concentration of A to the power of 2. So the relationship is when my concentration of A doubles, my rate will quadruples. So it means that when the concentration A increase by 2 times, my rate of the reaction will increase by 4 times. So it is second order in A and second order for the overall reactions. And the type of graph I will get when rate against A is a curve. So let's try an example questions. So based on the following reactions, determine the reaction order with respect to each reactant and the overall order for the reactions. So I have a chemical balance equation and a rate law given. So based on the rate law, the order for nitrogen oxide is second order, and the order for oxygen gas is first order, and the overall order of reaction is third order. And for question B, the order of reactions for CH3, CHO is 3 over 2. So my overall order of reaction is also 3 over 2. Based on the chemical equation given, there are 3 reactants, but in my rate law, I only have 2 reactants. So based on the rate law, I know that H2O2 is first order, hydrogen ion is also first order, and there's no hydrogen ion in my rate law. It means that it is 0 order for my hydrogen ions. So the overall order of reactions is from the reaction rate, reaction order of each reactant. So 1 plus 1, I can get the overall order of reactions is equal to 2, which is a second order. So it means that when you see the reactants is in the chemical equations, but it's not written in the rate law, it shows that the reactant is 0 order.
If you like my videos, please click like, share and subscribe to Madam YY channel.